All right, so I mentioned in class that after multiplication and division, we were going to move on to adding and subtracting. And it might not seem like that would be more challenging than multiplying and dividing, but you're going to see in a minute why it's a little bit more involved. So what we're going to do here is we're going to take those same rational expressions that we've been working with, but instead of multiplying two things like this or two things like this, we're going to be adding and subtracting them. And the reason that that's going to be a little bit more challenging is because, as we should remember from all of the math we've done up until this point, whenever we add and subtract two fractions, we have to have the same denominator. All right, so let's make a note of that because that's going to be an important component of what we're doing moving forward. All right, so let's just take a look at problem A here. And what we should be noticing is that we can't add these two things together, right? They're not fractions that have the same denominator, but we could add them if we were to give each fraction the component that it's missing. Right, so it would be fine to stay in the habit of factoring as much as you can and call this 2 squared, all right? If you'd like to factor the 6, you can, but really it's the denominator that's going to be the most important thing for us to factor. And what I want to recognize is, what does this first fraction need that the second fraction has? So in my denominator, I have a 2 squared here. It does not have a 5. So what I'm going to do is I'm going to give that 2 squared a 5. But if I only multiply by 5 in the denominator, it's going to change the value of that fraction. So I'm going to multiply by 5 over 5. And this is really just a 1, right? 5 over 5 is 1, so I can multiply by 1. And our second fraction has the 5 already, but what it doesn't have is the 2 squared. So I'm going to make sure that both of these numbers get a 2 squared, because that's really just 4 over 4, which is really just 1. All right, so now we can kind of piece this whole thing together, and I end up with a 15 plus a 24 all over, and 4 times 5 is 20, so that's where I'm allowed to push these two things together, right? Now that there are two fractions that both have a 20 for a denominator, I can combine them, and they're both over 20. I don't need to add those 20s together. And so what I end up with then is 39/20ths, which can't factor, right? We could check and see, can I rewrite 39, right? It would be 3 times 13, and 20 is 2 squared times 5, but I don't see any common factors anywhere, so there's not really anything I could do to simplify that, okay? All right, so that's as simplified as that one would get, all right? But let's take this to the next level, because you've added those fractions like that before in 5th grade. But now we're going to start using polynomials here. So in example B, we're lucky because we already have common denominators. So this is a case where I could actually just subtract these, right? I have a 2x plus 4 minus an x plus 4 all in my numerator over 4x minus 1 because I already had the same denominator. The important thing to remember here is if I'm going to subtract this whole thing, I should keep that in parentheses because what I'm going to need to do is distribute that negative now. All right, so that's going to give me 2x plus 4 minus x minus 4 all over 4x minus 1. All right, now some nice things are going to happen here. 4 minus 4 is 0, and I'll have 2x minus x, so I'll end up with x over 4x minus 1. And remember, there's nothing we can do here to cancel anything, so that's as simplified as that one gets. All right, so that's an example of where we already did have the common denominators. There was nothing that I needed to do to make these two fractions have the same denominator. So I could already just subtract them the way they look right now. Example C. Example C shows us that we don't have the same denominator anymore. So now that we don't have that, we're going to have to do some work. All right, so I have a 1 over x plus 3 plus a 4 over x minus 2. All right, so this is where we're going to kind of fall back on the same strategy we first talked about. What does this fraction not have that this fraction does have? And all I'm talking about is denominators here because I want the same denominator. Well, this fraction needs to get an x minus 2. So what I'm going to do is multiply this by an x minus 2. But obviously, I can't just do it in the denominator. I have to do it in the numerator as well. Now, what does this fraction not have that this fraction does have? Well, this fraction still needs an x plus 3. So I'm going to multiply by x plus 3 over x plus 3, which is really just 1. So now I can kind of FOIL this all out. I know that I can now write this over x plus 3 over x minus 2 because I now have a common denominator. So what am I going to have in my numerator? Well, I'm going to have a 1x minus 2 when I distribute that 1 plus a 4x plus 12. All right, and that ends up becoming 5x plus 10 over x plus 3 times x minus 2. And I should check to see if anything's going to cancel here. So 5x plus 10 could be rewritten as 5 times x plus 2. And so you're tempted to want to do something about canceling this, but there are no x plus 2's in the denominators, so nothing is going to cancel. So it turns out there's nothing I can reduce here. So my final answer then is just going to be 5x plus 10 over x squared plus x minus 6. And where did that come from? Well, that was just me putting this stuff back together at the end. All right, so once I've canceled everything, then I can rebuild the fraction and leave my denominator as a polynomial and my numerator as a polynomial. All right. Now, example D, I'm not going to finish, but we're going to start it together. And I'm going to want you to do this one on your own to finish it. So if I look at these two fractions, they do not have the same denominator, so I'm going to have to make that happen. So this first fraction is a 6a over 5a plus 1. And what this fraction does not have, that this fraction does have, is a 2a plus 1. So I'm going to make sure that I multiply this fraction by 2a plus 1 over 2a plus 1. All right, minus. Well, this fraction already has a 2a plus 1. And in my numerator, I have an a plus 2. But what it doesn't have, that it still needs, is the 5a plus 1. So I'm going to make sure I multiply that in both the numerator and the denominator. And when I'm doing that, all I'm doing is multiplying by 1. I can multiply by 1. It's not going to change the value of what I have. Now my denominators are the same. Sure, they're rewritten in an opposite order, but that doesn't matter. All right, I could put this term first or this term first. So my new fraction is going to have a denominator of 5a plus 1 times 2a plus 1 in whatever order you want to write them. And my numerator is going to be 12a squared plus 6a minus, and let's put these together. All right, I'm going to have a 5a squared plus a plus 10a plus 2. All right, now I can distribute there. I'm just trying to put this thing together. Minus 5a squared minus 11a minus 2 all over 5a plus 1 times 2a plus 1. All right, I'm not going to finish this. I want you to see if you can finish it. All right, so put this all together, see if there's any way for you to simplify it. All right, and then when we get back on Wednesday, we're just going to practice this. We've just got to get really good at both multiplication and division of these rational expressions. All right, so go ahead and finish this one on your own. Enjoy the long weekend, and I will see you guys on Wednesday.